is it difficult?
It's hard.
I don't think so, but this is really exciting because this is our last chapter.
Yay. Are you serious?
Yeah.
Oh my god, I'm so lucky. It's short too.
So, and it's a short chapter.
Just a test.
Oh, this is too short.
Yeah.
Nice button down.
There's only 3
Okay,
sections.
but we'll be in the south during the test.
Yeah, we'll talk about that.
It's fine. We have the whole rest of the semester.
So, I'm not sure how to arrange, yeah, I know that you guys are going to, so I was trying to figure out if I could squeeze it in before you left, and I didn't want to push it, so we can do it, well, no, we have to do a test, but we could do it after. We'll figure out the scheduling. I realized that I had these all created before remembering
At
the
least this is
schedule.
the last chapter, like it was the second last chapter, and you had
Right.
the schedule before we left. That would be a problem.
If you say this is the last chapter, so does that mean that after we're done with this, we're just going to be studying for the AP?
Yeah, there's one more concept that's kind of in the middle of chapter 8 that I teach, but then it's just going to be AP practice.
Because I realize I need a lot of review from doing
We
so many
still
things.
will have, this is pretty much our last chapter with like a traditional chapter test. From then on, it's just going to be like little, kind of like AP quizzes and some, when we do free response, we'll have some group work and like kind of teaching to the class
Wow.
moments, things like that.
I'm scared for the AP quiz.
So it'll be fine. Adam, you have a question?
Are we taking final also?
Yeah.
Oh,
What's the
come
final?
on.
Okay, we need to start. So
Next
Not for
math final.
seniors.
Should we say math?
seniors have a final too.
Dang it.
Okay, so integral as a net change. So this is the chapter where we take all the rules that we learned in chapter 5 and chapter 6 and we apply them, okay? It's not too bad, there's only 3
How do you apply
sections.
them all?
It's pretty bad.
Is it like the
It's not.
related rates?
It's kind of like the related rates of integrals. So the first one is actually something that we've seen over and over again, but now with integrals. So talking about particle motion, okay? There is some kind of, I don't want to say memorization, but there are some rules that you need to know. So particle motion. Oh, that's weird. So first of all, let's just remind ourselves like what velocity, if velocity is greater than 0, the particle's moving to the right. If velocity is less than 0, it's moving to the left.
It's almost as if those little like arrows are pointing which way. Because that one's
Exactly.
pointing,
It's pointing to the left, pointing to the right. So what else do we know? One of the things we talked about with derivatives was, or back when we did like position function and then velocity was the derivative of position and then acceleration was the derivative of that. So think about displacement is going to be the antiderivative of velocity from A to B.
Which is just the position.
Now, think about that. What is the antiderivative of velocity? That's going to give us our position function, right? Evaluated from A to B. So it makes sense that we take our position at B and subtract the position at A. So hopefully that makes sense how
That's how far it moved.
that's how far it, not necessarily how far it's traveled,
Yeah.
because remember it could go back and forth. It's the
Change.
end position minus the initial position. But sometimes we don't know the position function. Okay, maybe we only know the velocity function and we want to look at how the displacement over a certain time interval. So we can use an integral here. The final position is initial position plus displacement. That makes sense, right? I mean, if you start at a certain location and you add the displacement, you'll have your final position. And then total distance traveled kind of looks like displacement, but it's the absolute value of velocity, which we talked about also when we did the derivatives. Absolute value. Why do we need absolute value here?
So it's all positive movement.
Right, total distance, we want it all positive. So if it goes in the negative direction, we still want to count that as a positive distance. Okay, so the function v of t is the velocity in meters per second of a particle moving along the x-axis. So we want to use analytic methods to do each of the following. So for part A, determine when the particle is moving to the right, to the left, and stopped. Okay, so really simple. We already have the velocity over the time interval from 0 to 10. So basically factor this.
Why factor it?
Well, just for fun. No, there's a reason.
Add 3t instead of include there.
It's fine. So t equals, we did get t equals 8. So if I create a number line, so here's 0, here's 8, and here's 10. And I'm going to label that as v. Notice I put my 0 and my 10 because those are my endpoints. So if we choose a test number between 0 and 8 and plug it back in, do we get positive or negative? And then here, 8 to 10, say 9, we plug in, we get negative. Okay, so when is it moving to the right? So from 0 to 8, it's moving to the left. From 8 to 10, and it stopped when t equals 8. You can use parentheses instead of brackets if you prefer. That's fine. So find the particle's displacement for the given time interval, and notice here it says s of 0 equals 3. We also want to know well, there's two different questions. So one is the displacement, and one is the final position. We use that position as this is initial. That's the initial position. Oops. I don't know why. Thanks.
Like what?
Okay, so displacement. The integral from 0 to 10. And we have 24 minus 3t dt. All right, go ahead and. What do we have? 24t plus 3t squared over 2. Oh, thanks. Okay, so 24t minus 3t squared over 2. And really we just have to plug in the 10 because when we subtract the 0, we don't need to worry about that. So, what do we get for that? Okay, and we get 90.
If I did that right.
And what are the units here? This was in meters. So what does that actually mean? That means that the particle ended up 90 meters to the right from where it started. So the displacement would be 90 meters. You don't have to say to the right. I mean, sometimes they'll ask for an explanation, but obviously since it's positive.
If it was left, it would be negative.
Right, if you got a negative answer, that's fine. You can have a displacement that's negative. It just means you ended up to the left of where you started.
I'm gonna do that. We didn't find
Oh,
the
you're right.
final position. I got you, Casey.
My goodness. Final position is going to be the initial position, which was 3, and add the 90. So we end up at a position of 93 meters. Okay, the last part is the... Right. So once you have displacement, then it's easy to find the final position. You just need to have that initial position and add. Now, sometimes we don't have the initial position. We might have the position at 5 seconds. So I'll show you also a way that we can figure out the final position based on any position at a particular time. Okay, the last part, what do we do for total distance traveled? Okay, so the absolute value. So how would you do absolute value of 24 minus 3t? So there's a couple ways we could look at this. If you can see from 0 to 8, it was positive. So you could do the integral from 0 to 8, and then you could do the integral from 8 to 10, and then just basically subtract it because it would end up being a negative. Does that make sense? Like breaking it up into 2 parts. Just to save some time, though, let's... So we want from 0 to 10 of the absolute value of 24 minus 3t. To save time, if you want, you could do this on your calculator. Well, did you understand what I was saying with breaking it up into
One more
2
time.
intervals? Because we did. Okay, so we could break it up. I'll show you how to do it by hand. It would basically be the integral from 0 to 8 of 24 minus 3t dt, and then I would subtract the integral from 8 to 10 of 24 minus 3t dt, because the velocity was negative here, I am basically going to end up subtracting a negative, which would make it
Is
positive.
this problem calculator okay?
This would be fine.
102.
102?
109.9999.
No, 101, no, 109.
101, that's what I meant. 102.
That's what I said.
Oh, it's high.
It's okay. If it's 9 repeating, that's... Didn't you ever see the proof where 0.999 repeating is really equal to 1?
Right, because 1 over 1 9. 1 9.
I'll show you that another time.
Is it what,
Neat
like
trick.
the whole point 1 at point 9, 1 9 is point 111 and then.
So anyway, if you 0.9 repeating is actually equal to 1. So it's really 102.
You just say touch rounding and then you prove it. That noise though. What just happened?
I scrolled too quickly. Okay, you want to try this next one on your own?
No. I guess.
Isn't it fun?
Heck no, dude.
There we go.
No,
There's the
it's fine.
enthusiasm.
Come on.
Really fuzzy today, I'm having a hard time.
It's exactly like the last one. I threw in a fine function.
No, she's not. No, we're not.
Look at this.
All on the screen cap. That's great.
Oh, Walker, I'm gonna
Big screen casting right now?
We're not.
some picture I took last night, and it's the puppy that's about this big.
Oh,
Can you put it on this one?
what kind of puppy is it?
I don't even know.
Yeah, I mean,
We're not.
Yeah.
I don't know.
Screencast.
So it's just Jackie. It looks like a bear.
okay. So, what are we solving for? We're solving for t, and 3t is going to be equal to the sine inverse of 0. Just keep in mind, we only want to have values of t that are between 0 and pi over 2. Where is sine 0? So think about on the unit circle, where is sine equal to 0? So at pi and at 0. Right, we would keep going. Like, for example, it would be, when is sine equal to 0? At 0, at pi, at 2 pi, at 3 pi, at 4 pi, and so on. Also the negative we would just keep going just to make sure that we get all the answers that are between 0 and pi over 2. But this just results in 2. Right, t equals 0 and t equals pi over 3.
And they both work. Well,
And-
that's when you do the n pi thing, huh?
Right, so, well, what does this mean? This is actually where the particle is stopped, because this was when velocity was equal to 0.
Yeah.
So it's stopped. Now we're going to make a little number line.
So power of three works from this one.
Yeah. So here, I have 0, I have pi over 3, and it stops at pi over 2. So this is v. So again, we just kind of make like a number line, just like we did with the derivative. I mean, really, velocity is the derivative of position. We don't have the position function right now. We could find it if we needed. So pick a test value in between 0 and pi over 3.
Maybe it's positive.
I have a 6.
Can we just think of it like?
I actually did 1.
That's it, positive.
Why would you pick 1?
I don't know, I did it wrong.
Okay. I'm sorry, Mom. I didn't mean for it to come out that way.
Because once you.
But it is.
I was like, what?
It
I would
is.
pick like
Pi over two.
It's
pi over 6 or pi over 4, something
But
like that.
Ms. Casey, I'm not wrong.
Oh, okay.
It's between 0 and pi
But
over
let's
3.
say you don't have a
What did he
calculator.
say? What did he say?
Okay, what do we get?
I said 1.
Is it positive or negative?
Positive. They chose 1 and it worked.
And what about something between pi over 3 and pi over 2? That might be a little more difficult.
1.5.
Is it negative? It's negative. Guys, you know what a sine curve looks like also, right? So
No.
obviously it's gonna switch. So it's moving to the right from 0 to pi over 3, and then it's moving to the left from pi over 3 to pi over 2, and it stopped at t equals 0 and pi over 3. It's still, okay, so because we're looking at a certain time interval, at pi over 2, if you actually plug pi over 2 into the velocity function, you get a positive velocity, which means at pi over 2, it's still moving in a positive direction. It's not necessarily, let's just say we don't know what's happening before 0 and pi over 2, and we just want to take like a snapshot of that interval. So at pi over 2, it's still got a forward velocity. It's like a car. Like if you say, okay, car, you want to look at a car from 0 to 60 seconds, and you can figure out the miles per hour at 60 seconds, it doesn't mean at 60 seconds all of a sudden it stops. It still has a positive velocity at that moment. Yes. Okay. So you remember the U substitution, we just learned it. How could we forget? So displacement.
Never forget.
Ms. Casey, we learned it. And Erica, it's good to see.
You learn.
I think the screencast should show a little window of what's going on in the classroom too.
That sounds great.
Do you just want to be
Hi, Jackie.
This one might be pretty bad,
Cut.
I must say.
Cut it. Restart.
All right, what are we going to make U? Okay, so U equals 3t.
Calm.
Now, some of you were, I noticed there were a couple problems on the test where you ended up with a coefficient and there was already a coefficient here. So, do you see how there's a 6 here?
2du.
If I just multiply both sides of this by 2, right? Watch. If I multiply both sides of the equation by 2, I get 2 du is equal to 6 dt. So I can replace 6 dt with a 2 du. Right, and I'll put the 2 out front from that point. But before we do that, I'm going to do the quick change of bounds. So u of 0 is u. Right, make sure you plug into u. And u of pi over 2 is 3 pi over 2. Okay, so now we're going to rewrite this. It's going to be from 0 to 3 pi over 2 of sine of u du with a 2 in front. Antiderivative for sine is negative cosine.
Negative
So negative 2 cosine of u evaluated from 0 to 3 pi over 2. Okay, if you don't want to use u and you want to go back and use your t, then you would use your original bounds. But I will always, I don't know, I like to just change everything. Because sometimes what happens is students forget to go back and go back to the original, and they just accidentally plug everything in. Okay, what's cosine of 3 pi over 2? 0. What's cosine of 1? Or sorry, cosine of 0 is? 1. 1. So it's negative 2 times negative 1, so we get 2.
Like, so that's 2 pi over 2 is 0.
Right. Do you want me to write out the steps for that?
Yeah, please.
Okay, so it's negative 2,
Oh, I ran out of part 2.
0 minus 1. So it's positive 2. Okay, final position. Did I forget my units? It was meters again? Was it meters?
Yeah.
Okay, so our final position, so we go back. This is our initial position. So it's going to be, guys, please. 3 plus 2, so we get 5 meters. And then for part C, we want total distance. And this we could do on our calculators, that's fine. So it's going to be the integral from 0 to pi over 2, absolute value of 6 sine 3t dt. Again, you could break this up into 2 separate integrals. The 0 to pi over 3 would be already positive, so we don't need to worry about changing that. But pi over 3 to pi over 2, that's going to end up being a negative value, so we would change it to positive. We take the absolute value of that.
That's 6.
You got 6. Okay. Okay, one more. Look, we only have like 5 minutes, so let's just see if we can. This isn't that long.
That's not worth it.
Okay, it's totally worth it. Let's go.
Yay!
We're really doing it for you. We don't want you to have to do any more grading or get stressed about anything else in life.
Not great.
It's really important. We will grade your papers.
Why don't we do it?
It's really
Why don't we
important
go
for
around?
you to stay calm and not stress out.
What do you feel like?
Stress level.
So we are given the acceleration. A car is moving with initial velocity of 5 miles per hour. Okay, so it's accelerating at the rate of 2.4 t miles per hour per second for 8 seconds. So remember, acceleration is, right, that's the third derivative. So it's like per unit of time per unit of time.
Second derivative. I messed up.
Right, so it's miles per hour, and then this one just happens to be per second. Okay, so do you see what it's doing? So it's accelerating at this rate for 8 seconds. Okay? We want to figure out how fast is the car going when the 8 seconds are up. So, right, so we want to figure out what? The velocity when t equals 8 seconds.
But it's
It just means at the end of the 8 seconds.
The anti-gravity acceleration.
Correct. So think about if acceleration, guys, and you had one like this on, no, I'm kind of giving away. You had something like this on the
Oh.
test, where it was the second derivative, the one you just took yesterday.
Yeah. Oh, I think I did that.
You had, what's another way to write acceleration?
dx squared over dt.
Because we have an arm.
Oh, that's supposed to be an S, I'm sorry. You had a homework problem, you had a problem similar in the practice test, and you also had one on the homework assignment that was like this.
Yeah, I did.
I just threw in an added piece of finding the position function. So, basically you had to work backwards twice. Okay? So, if you have the second derivative, but I want to find I want to find ds dt. So basically for A, right. Which, okay. So how do you find the velocity at 8 seconds? Okay, so go ahead and do that.
Oh my god, it's on.
Oh no.
Your batteries died?
No, I did that on purpose.
Casey. No.
Well, we're running out of time, so I just wanted to make sure.
They should just copy what we put in the thing.
Yeah.
Make it do
Well, we're running out of time, so I was going to my last year's to just show it. And then what we'll probably do is we'll pick back up from here.
So I'll just wait, we'll do it tomorrow.
Okay, so I just wanted to say, I know, I just wrote this stuff up, so you guys can write a couple of notes down, but then we'll pick it back up. So from 0 to 8 of 2.4 dt, is that what you guys started doing? Doing an integral? No?
I tried to start and then I just couldn't do
What?
it.
So just set it up from 0 to 8 of 2.4 dt.
I don't think it went 244 miles.
No, it did not. How far did the card travel? Oh, it looks like it.
I got 244.8. If you divide by 2.
Yeah, so remember that, and I'll explain, if this is miles per hour per second, when you take the antiderivative, it gets rid of the last unit of time, it gets rid of the second.
Yeah, miles per
So you're
hour.
gonna get miles per hour. Did you follow that? Like when you integrate, you're gonna get rid of that. And then what happens if you would integrate again?
You lose per hour.
You would lose the per hour.
So you get miles.
But just make sure that you're integrating with respect to hours. Isn't that interesting? Because remember, we have different units of time.
Yeah.
And that's why we have practice problems that we're going to be doing. So, all right, we'll pick it back up on Friday. You won't?
Look down, up, down.
You should end that screencast before it gets any worse.
Hi, Jackie.
Hi, Jack.
Keep dancing, Jackie.
Bye,